Hi, I'm Jonathan. Today I'm going to do a presentation of Euler's method to approximate the solution of the given initial value problem. Euler's method is a simple numerical technique for approximating the solution of a differential equation. It helps us estimate how something changes step by step using the rate of change. Now I'm going to explain the process of Euler's method and derive its formula using my hand-drawn diagram. For the given equation, 12 by dx equal a squared plus 1 over y, we can calculate to get the general equation y squared equal 2 over 3 h2 plus 2x plus 1 to draw the graph. So in here, if we draw a tangent line at a0, y0, we can see rise and run. So according to the equation of slope, which is f of a0, y0 equal rise over run, we can substitute run with h since h is the increment added on the x-axis. So we get rise equal h into f of a0, y0. In order to get y1, we need to add y0 and the rise. So we get y1 equal y0 plus h into f of a0, y0. Finally, we get the Euler's formula for the n value, which is yn plus 1 equal yn plus h into f of x1, yn. Now we're going to calculate the value of y1 using the respective formula for each column. The initial values of x and y when n equals 0 are 0 and 1 respectively. Firstly, for column xn, we're going to use this formula h of n plus 1 equal xn plus h. For example, if we want to get x1, we need to add x0 and h. Since h equals 0.1 and x of 0 equal 0, we get x1 equals 0.1, and if we substitute the values like this, we will get the rest of the values in xn column as you can see here. Next, for the slope column, we're going to use the formula which is f of xn, yn equal xn whole square plus 1 over yn. As an example, if we want to get f of a0, y0, we need to substitute the values of a0 and y0 in this equation, and then we will get f of a0, y0 equal 1. And if we substitute the values in the same way, we will get the rest of the values in f of xn, yn column as you can see in here. For the yn column, we're going to use the formula which is yn plus 1 equal yn plus h into f of xn, yn. For example, if we want to get y1, we need to add y0 and the product of step size and the slope at that particular point, which is a0, y0. So we get y1 equal 1.1. If we continue to calculate the same as this, we can get all the values in yn column. According to the problem, we want to get the value of y1 is equal 1. Therefore, the value of n is 10 as the subsize is 0.1. So, in order to get the value of y10, we need to add y9 and the product of step size and the slope at the point is 9, y9. So, we get the final value of 1.911. Now, let's take a look at the value of y1 is equal 1 via general solution method. The answer is 1.915 up to 3 decimal places as you can see in here. So, we can simply find the approximation error, which is the difference between the two values we got from the Euler's method and general solution method. So, we get error equals 0.004. And we can also find the relative error percentage using the formula, which is error over the value we get from general solution method into 100. And so we get 0.209%. So finally, we can conclude that Euler's method can give a group approximation, but not the exact answer. And the more we reduce the step size, the further the error will decrease. Thank you.